Hey guys, in this lesson we're going to talk about how to complete the square. Completing the square is just one of the many methods that we have in order to solve a quadratic equation. When we complete the square, we are essentially forcing our quadratic expression to become a perfect square trinomial. Let's look at the first two examples. Here our goal is to determine the value of c that would make both of these a perfect square. We have two ways that we can do this. The first of which would be to use the box method. In the box method, I'm going to place that first term in the top left-hand corner, and then to figure out what goes in the top right, and in the bottom left, we're going to split up that middle term, that negative 12a, in half. So it's going to become negative 6a and negative 6a. We don't yet know what goes in that bottom corner yet because we don't know the value of c. So in order to figure out the value of c, we're going to first start by figuring out the two binomials to multiply to give us what we already have. So in order to get a squared, I would have to have a times a. And in order to get negative 6a, I would have to multiply a by negative 6. And so I'd have negative 6 and negative 6 in the other two spaces. That will allow me to figure out what goes in that bottom corner, because negative 6 times negative 6 would give me positive 36. So this tells me that my value of c is positive 36, and that my new perfect square is a squared minus 12a plus 36. We'll do the same thing for b. So t squared will go in that first box, and then to figure out what goes in the next two boxes, we're going to divide that middle term in half, so 5 over 2 times t. Because 5 is not even, we're just going to leave it as 5 divided by 2, since that's what we get when we divide it in half. And now we're going to figure out what multiplies to give us what we already have. T times t would give me t squared, and 5 over 2 times t would give me 5 over 2t. So that just leaves that bottom box, which would be the product of 5 over 2 and 5 over 2, which would be 25 over 4. So I know that c is 25 over 4, and I know that my new perfect square trinomial is t squared plus 5t plus 25 over 4. Now we said that there were two ways that we could approach this problem, the second of which is to use the formula b divided by 2 squared. In a, b was negative 12. And so if I do negative 12 divided by 2 and I square it, that's going to be negative 6 squared, which is 36, which is the same c that we got using the box. If I'm looking at the second example, b was 5, so 5 divided by 2 squared. Since 5 is not even, we're just going to leave it as 5 divided by 2. And if I square 5, that's 25 over 2 squared, which is 4. And so my c is 25 over 4, which is the same thing we got using the previous method. Now remember, completing the square is just one of the ways that we have to solve a quadratic equation. So let's take a look at the following equations and solve them using completing the square. Our first step is going to be to move the constant to the right side of the equation. So if I look at a, that constant of negative 13 is already on the right side of the equation. So I can move on to the second step, which is to find our new value of c, either using the formula b divided by 2 squared or using the box that we learned in the previous method. So if I use the box, c squared is going to go in that top corner. We divide 14 in half, so it's going to be negative 7c and negative 7c, and we're going to use this to determine our new value for our c. So c times c gives me c squared. Negative 7 times negative 7 would give, or negative 7 would give me the negative 7c. And then if I multiply negative 7 and negative 7, that would give me positive 49. So my new constant is positive 49. We're going to add that new constant on both sides. Now the reason why we have this constant, remember, is to make ourselves have a perfect square. So now I have a perfect square on the left, but I also have to add the 49 to the right so that my equation stays balanced. I'm going to factor this perfect square now. This is going to be c minus 7 squared. And if I add negative 13 and 49, that gives me positive 36. Now I can take the square root of both sides, so we can solve using the square root property that we learned in the previous video. C minus 7 is going to be equal to 6, and c minus 7 is going to be equal to negative 6, since the square root of 36 is both 6 and negative 6. So when I add 7 on both sides, I'm going to get c is equal to 13, and I'm going to get c is equal to positive 1. Let's look at the next example. So here we have t squared minus 10t is equal to negative 9. Our first step is to move the constant to the right side, which is already done for us in this case. Now our next step is to find the new value of c. So to find our new constant using the formula b divided by 2 squared. So b is negative 10, so I'm going to do negative 10 divided by 2 squared, which would be negative 5 squared, which is 25. So my new constant is 25, and we're going to add this new constant to both sides of my equation. Again, we're adding it to both sides so that we have a perfect square on the left, and we have to add it to the right to keep it balanced. I factor my perfect square, so it's going to be t minus 5 squared is equal to positive 16. I square root both sides. This is going to give me t minus 5 is equal to positive 4, and t minus 5 is equal to negative 4, since the square root of 16 is 4 and negative 4. I solve this, I'm going to get t is equal to 9, and I'm going to get t is equal to positive 1. Let's move on to c. So here we have m squared plus 6m minus 7. Again, my first step is going to be to add this constant to the right, so I'm going to get m squared plus 6m is equal to positive 7. Our next step is to find our new c using the formula b divided by 2 squared. So b in this case is 6. 6 divided by 2 squared, that's 3 squared, which is 9. So I'm going to add that new constant to both sides of my equation. So I'm going to have plus 9, 7 plus 9. We're going to factor our perfect square trinomial that we have on the left, which is m plus 3 squared is equal to 16. And then we're going to square root both sides. Remember that 16, the square root of 16 is going to be both 4 and negative 4. When I solve, I get m is equal to 7, and I get m is equal to 1, my bad, and m is equal to negative 7. So those are my two solutions there. Now remember that we don't always have easy, simple solutions, so let's look at some where we're left with a radical in our answer. So if we're looking at this first example, again, our first step is going to be to add 23 on both sides. So we have y squared minus 10y is equal to positive 23. Our next step is to figure out what our new b is going to be. So that's going to be negative 10 divided by 2 squared, which is negative 5 squared, which is 25. We add that to both sides. We get y squared minus 10y plus 25 is equal to 23 plus 25. We factor the perfect square trinomial to y minus 5 squared is equal to 48. We take the square root of both sides. We get y minus 5 is going to be equal to plus or minus the square root of 48, which can simplify to y minus 5 is equal to plus or minus 4 square roots of 3. We would then add 5 to both sides. Remember that we're going to put the 5 in front. So it's going to be y is equal to 5 plus or minus 4 square roots of 3. Now if we wanted to approximate this, we know that 4 square roots of 3, the decimal approximation would be 6.9. So we could rewrite this as 5 plus 6.9, or 5 minus 6.9. And so our two answers here would be 11.9 and negative 1.9 if we were to round this to the nearest tenth. If we look at b, we know that we have to first start by factoring out the GCF. So my GCF here would be 4. We don't want to factor out the n because we still need that part for the perfect square. So we have 4 plus 4n is equal to 24. I'm going to also divide by 4 here to get rid of that 4. It's going to make my life easier in the long run. So it's going to be n squared plus 4n is equal to 6. And now I'm going to find my new b. So we're going to take 4, or my new c, so we're going to take b divided by 2, so 4 divided by 2 squared, which in this case is going to be 2 squared, which is 4. So I'm going to add 4 to both sides. So I'll have n squared plus 4n plus 4 is equal to 6 plus 4. I'm going to factor this. This is going to give me n plus 2 squared is equal to 10. Square root both sides. I'm going to have n plus 2 is the square root of 10. I'm going to subtract 2 on both sides. That's going to give me n, or plus or minus the square root of 10. So I'm going to get n is equal to 2 plus or minus negative 2 plus or minus the square root of 10. And then, again, the square root of 10 is simplified, but if we wanted to change this to a decimal, the decimal approximation would be 3.2. So I'd have negative 2 plus 3.2, and I'd have negative 2 minus 3.2. So my final answer would be 1.2 or negative 5.2. This is how we solve quadratic equations using completing the square.